Hello and welcome back to our next maths lesson. And we're continuing to build the skills today that we need to use going forwards that will help us when we go further on in our fractions work. We've talked about equivalent fractions, and that's one of the skills we need. And today's another skill, which is looking at fractions that are greater than one. And this will look at mixed fractions as well as improper fractions. So before we start, here's a little recap. So if you pause now and have a go at this one. Okay, so first off, 24 divided by 4 is 6. And then how many tenths make one whole? So how many tenths do I need in order to make one whole? Well, it's 10. In that case, how many tenths make two wholes? So if I had two bars each split into 10, how many would I need to make all of them together? That'd be 20. And then how many hundreds are there in 5 wholes? Well, if I took one and split it into 100 parts, to get the entire one, I'd need all 100. So if I wanted 5 whole ones, I would need 500. So here's 7 sevenths, and you can see that all 7 of the parts are coloured in. We've got all of it. We've got the whole. So that's 1. Then we've got a further 2 sevenths here. And what you're looking at is thinking about, sorry, okay. If we've got 7 sevenths here, which is 1, and then we've got 2 more sevenths here, there, how many sevenths do we have in total? How many do we have all together? And there are 9 sevenths in total. So first off, we know they're sevenths because each of the wholes, if we think about each of these bars being one whole, we split each into 7. So it's still sevenths. But then we count how many we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. In total, we have 9 sevenths. And that counts as 1 whole 1 and 2 sevenths. And you could write it that way as well. So 9 sevenths is the same as saying I have 1 whole 1 and 2 sevenths, because that 7 sevenths is that 1 whole 1. Here's another one. There's 7 sevenths, which is equal to 1 whole. And there's 2 sevenths, which are 7 sevenths all together, or 1 whole and 2 sevenths, which is what we just said. So here we have 2 sixths, and then we have 5 sixths. How many sixths do we have all together? Have a think. Well, yes, we have 7 sixths all together. So what does that mean we have? We can tell that because we've got 1, 2, 3, 4, 5, 6, 7. 7 sixths all together. Now 7 sixths, I can move them. So those 7, this would actually be slightly further over, so this would be filled in here. We've got this whole one plus this additional one here. So we've got 1 whole 1 plus 1 sixth. So we could write 7 sixths as 1 whole 1 and 1 sixth. And you can see that because we've got 1 7 is 1 more than 6. So we've got 1 more sixth than 1 whole 1. So have a think about this one. Have a look to see how many there are all together. How many whole ones can you make, and how many spare fifths do you have? Pause now and have a look. Think. Okay. So this is quite interesting because it links back to our division work, doesn't it? And you're thinking about dividing a number by how many parts you have and how many you have left over. So how many fifths do we have in total? Well, there are 11. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if that's 11 fifths, that means we can fill up 2, so I can move that one there and that one there. That fills up that one. And then we have 1 left over. So we'd have 2 and 1 left over. If we were to divide 11 by 5 fifths, we get 2 with 1 remainder. We can divide it 10 equally 5 ways, which is 2, and have 1 left over. Interesting how it links to our division. Here we have how many thirds are there? There are 3, so we have 3 halves. So how many halves are there? So that means we've got 1 whole one and 1 half. Nice and straightforward. So can you have a go at these questions for me? The first one's using a part whole model. They split them into wholes and parts. So you should make it quite easy when thinking about how many whole ones and how many parts you have. And the second one here, doing similar thing, 5 thirds, how much is that equal to? It's in wholes and thirds. And put that all together to get the answer. Have a go, see what you think. Let's have a look at the answers. So the first thing we're thinking over here is we can easily see that 7 fifths, there's 5 there and 2 there. They split them into how many whole ones and how many parts we have. So we have 1 whole one with 2 parts. 2 parts are there. Then the same here, 2 whole ones and 3. So 2 whole ones and 3 fifths. Then 3 whole ones and 1 quarter, or 3 whole ones and 1 quarter. You could write this as in 2 and 3 fifths, and you could write this as 3 and 1 quarter. Always make sure that the whole number looks bigger than the fraction as well, because it just helps you see the difference between them. Up here, 5 thirds, you could draw it out to help you. There's 5 thirds, that's 1 whole one, 2 thirds left over, which is written like this. And the same goes for the rest of them here. So 12/6 is an improper fraction. And all we mean by an improper fraction is when the numerator is larger than the denominator. Whenever you get the numerator being larger than the denominator, it's an improper fraction. But it also shows that it is bigger than 1 whole one. And then you can write that as a mixed fraction by writing it as a whole number and the part that's left over. So let's do 12/6. There's 6 sixths plus another 6 sixths. So in total, we have 2 whole ones. Then we've got 18 sixths. There's 6 sixths. There's another 6 sixths. There's another 6 sixths. How many do we have in total? 3 whole ones. Does anyone notice a pattern at all? This is interesting because what we've said is 12 sixths is the same as 2 whole ones, and 18 sixths is the same as 3 whole ones. Well, here's the trick. Remember, our division sign is our fraction symbol is the same as a divide sign. And you divide the top by the bottom. So 12 divided by 6 equals 2. And 18 divided by 6 equals 3. And you can see that here. And that's where it comes from. And that's actually what a fraction is. It's the top number divided by the bottom number. And this is how it always is the case. And if you have a remainder, then that's how many fractions, pieces, you have left over. So that's our link there. 6 goes into 18 3 times, or 18 divided by 6 is divided by 3 is 6. That's 3 whole ones. How about this one? 20 fifths. How many do we think there are before we go any further? Let's have a look. We've got 5 fifths, another 5 fifths, another 5 fifths, another 5 fifths. That's 5, 10, 15, 20 fifths in total. That is 4 wholes, because 20 divided by 5 equals 4. Okay. How about 10 sixths? There's 6 sixths and there's 4 sixths. So it equals 1 whole 1 and 4 sixths. Now let's think about that in terms of our division. 10 divided by 6. How many whole sixths can I fit in? I can fit in 1 with the remainder 4. That remainder 4 are these 4 sixths that are left over. So another way to write that would be 1 with 4 sixths. And where we get this bottom number from is what we're dividing by. And that, in essence, is the link between the division that we were doing and the fractions we are doing. And actually, what fractions are, which is just a division. Have a think about these and give them a go for me. Okay, so 11 thirds. Now we think, okay, let's divide 11 by 3. 3 goes into 11, 3, 6, 9, can't get to 12. So 3 whole ones, and then I have 2 left over, so that'd be 2 thirds. 9 divided by 2, I can fit 4 whole ones in with 1 left over. 20 divided by 7, or 7 27ths. I can definitely fit it in twice, which is 14. But the third one is 21, which I can't fit in. So I've got 2 whole ones plus the 6 that I have left over. And that's where we get them from. And actually, it makes it much easier thinking about it that way, rather than having to draw them out the entire time. But of course, if you wanted to, you could draw them out and it would get you to the right answer. So which one's bigger, 7 halves or 7 fifths? Now, the reason we ask this is because, look, our numerator is the same. So how do we know? And this is where the interesting bit about the denominator comes in. Actually, the smaller the denominator, the larger the fraction. So a half, you only need 2 to make a whole, but I need 5 fifths to make a whole, which means I need more to make a whole, which means each fifth is actually smaller than a half. And you can see that when you draw them out. So there's 7 halves, that's 3 and 1 half. And there's my 7 fifths. I need 5 of them to get 1 whole, and then I have 2 left over to make my 2 fifths. Whereas on this side, I've got 3 with 1 left over. So obviously, 7 halves is larger than 7 fifths, and you can see that when drawn out. So when the numerators are the same, the greater the denominator, the smaller the fraction. And that's quite an interesting weirdness to fractions that some people don't quite understand. And it's just a case of when you think about the whole, if you're splitting it into 2 pieces, you get much more when you take 1 piece, rather than when you split it into 5 pieces, you only get a small part. Think of it in a cake. If you had to share it 5 ways, you'd only get a small slice. But if you only had to share it twice, you get half a cake. So that's where that comes from. Same with this one. Give it a shot. 24 divided by 6, actually, we know we can fit 4 of those in. And then 16 divided by 4, well, 16 divided by 4 is also 4 whole ones. So these are the same. And these would be considered equivalent fractions because they're the same. They are improper fractions. And actually, if you think about it this term, we're just saying 4 equals 4. And obviously that means they're the same, much like equivalent fractions are. So have a think about this. Is 2 wholes and 5 fifths larger than 9 fifths? Are 28 sevenths larger than 12 thirds? 9 sixths or 17 eighths? 20 tenths or 20 ninths? Which one's larger and smaller? Have a go. Okay, let's have a look. So 2 wholes and 5 fifths or 9 fifths? Well, 9 fifths, we've got only 1 whole one with 4 left over. So 2 whole ones are going to be larger. 28 sevenths. 28 divided by 7. is going to be 4. And then we've got 12 thirds. 12 divided by 3 is also 4. So they're the same. 9 sixths. So that's one whole one. That's 6 of them with 3 left over. Now, actually, 3 sixths are the same as R. We don't need to worry about that for now. 17 eighths. So we've got one whole one, we've got another whole one, and 1/8 left over. So 17 eighths is larger. Here, 20 divided by 10 is 2. 20 divided by 9 would be 2 with 2/9 left over. So that would be larger. Have a go at these for me. Give it a shot. See what you can do. Pause now and have a go. Okay, just remember, if you get stuck, draw it out. If you draw it out, you shouldn't have too much of a problem. Just make sure you're thinking about the size of your fractions. And if you need to draw them out, but it gets you to the right answer, where's the harm? It still gets you there, right? So our answers. 12. The first one's just up here. First off, are relatively straightforward. You're just converting them into wholes. And then the last two have a few left over. The next one, Whitney takes 26 muffins. And they're packed in groups of 4. So we've got 26 fourths. How many boxes, the whole boxes, will she fill is what we're asking. So a whole is the box. They pack into groups of 4. You have 26 of them. So 26 divided by 4 is 24, which is 6 with 2 left over. So she'll fill 6 of them, and she'll have 2 that are one box which will only have 2 in. And that's why we get 6 boxes. How many more muffins will it need to fill in another box? Well, we've actually done the calculation already. In order to get to 4, we need 2 more to get to 4/5. So she needs 2 more muffins, and you can explain that in any way you like. How does writing 26 over 4 help you answer this? And we've talked about that as to why it works up here. Then we've got write our calculation. So we're doing greater than, less than, or equal to. So the easiest way to do this is to write it out, or you think about what 5/4 is the same as 5 divided by 4 is 1 1/4. So obviously 2 3/4 is larger. 2 wholes and 3/4 or 15/4. Well, 15/4, that's 15 divided by 4. So you're looking at being 3 3/4, which means that's larger. 2 wholes and 3/6, 16 is 2 wholes, so it makes 12 with 3 left over. 2 wholes and 3/8 or 15/8. 15/8 is only 1 7/8. So that's smaller than that one. And then you can do the similar amounts on this one. You know this, you don't really have to think about, because if you know that is, you've got the denominators being the same. Sorry, you know the denominators are the same. So because this is, each part is bigger, this is going to be bigger. But in this case, you'd have to work out what that is. 15 thirds is the same as 3. Sorry. 15 thirds is the same as 5, because 15 divided by 3 is 5, and 20 divided by 4 is 5. So they equal one another. And this, you're just partitioning the wholes and the parts out in the way that they've done it. Or if they've taken part of it, so in this case, they've got 4 wholes and 1, well, you've got 1 whole left and the part left. And here they've taken 13 of the fifths out. How many do you have left over? Well, 13/5 is 2 wholes. You'd have to work out that that's 2 whole ones and 3/5. So then you'd need the other 2 whole ones to get the answer. So well done today. Enjoy the rest of your day. And if you need to, just go back through, have a look through what we've done. And I'll see you in the next lesson. Goodbye.